how you would approach a problem beyond the academic knowledge that you get. So these are not more than 3 to 4 hours of material. We are not the regular 45-hour semester material that people look for. So after COVID started and in 5 years, I said we have to do something for the society back. So I started a mentorship program where every summer I used to teach, mentor people in various aspects. For the first 2 years, I did it purely on analog design. Then a couple of years back, my interest in education moved to see how AI can come into the education, and then how AI can come into engineering learning. So I had 2 cohorts of undergrad students who helped me in understanding how AI can enter into these courses, and how especially engineering learning or microlearning concepts that came into being. And I found a lot of happiness doing that, because these are very simple things that we have always been doing, but never in a structured way. So this came out as a very structured work. So the first one on analog circuit design, where I have roughly 6 topics where I encourage master students to do a 1 semester internship with me, and the other 2 are for bachelor students. So one thing people ask me is, okay, what do you get out of it? So I said, I don't get much, but I get to brag about my internship program, where in the last 3 years, we have had 9 conference papers in India's top conference, or at least top league conferences. So VLSI Design Conference, IEEE Connect, and VLSI Startup, and VDAT. These are the 4 conferences where people have published, and people on education and learning have gone into Technology Engineering Management Conference, which is the leading conference of the TEMS Society. So that was in the year when I was the TEMS chairperson I wanted to drive. Seeing this, I was invited to be the co-supervisors of many masters projects, 2 of which are complete, one in India and the other one is from Algiers. So this is one output that I get as part of the tech consulting and mentorship program. For the people who are interested to know what work I have done in the last 17 or 18 years, so these are the, starting from my PhD work, which is on a lab on a chip. And lab on chip basically is for doing a capacitance change measurement to the tunes of femtofarads and attofarads of change detection that we do. And for that, I used it on one application, which is for cancer cell volume rate growth identification. Instead of doing it in an optical way, I proposed a method where you could do it in an electrical way. And the sensor entire system is on a credit card size form factor or visiting card form factor. So if you can imagine, right, the entire chip or the entire system is slightly bigger than this one. So it is that simple, where instead the optical systems will be bigger and bulkier. This is a bread and butter circuit which is happening for the last 8-9 years for me, which I work on high-speed SerDes designs, where we do 1.25 to 40 Gbps per pin data rate of work. For each one of these high-speed SerDes, you need to build clocking circuits. So clocking circuits starting from 1 GHz to 5-10 GHz using NIC oscillators and LCPLS up to 32 and 56 GHz. After joining Intel, I predominantly joined Intel only to do this work. Now this particular team is not working, they have moved out. So this work was on high bandwidth memory, where you are trying to give a lot of memory from a processor, or from a memory to a processor and back in a very short duration. So the throughputs that we are targeting about 1 terabit per second. And that is the aim that we are trying to do. And that has led to a lot of work from our team being presented at various fora. Last projects are based on IoT, where we wanted to see how IoT projects can lead to students. So one of the recent works are something called Agile Frequency Synthesis. There's a most recent work which we did, where how do you do, depending upon what is the power requirement, how do you generate different frequencies to operate different systems. And along with that, a lot of energy harvesting and LDO based works come into the picture. The most recent work, which was, like I said, on the Agile Frequency Synthesis, was to use for wake up receivers. So where you don't want the receiver to be always active. So you put it to sleep, only when you want it to come up, you wake it up and then do the reception and transmission of the data, which is good for all your remotely operating testing equipment. And this is more on the social interface. This is something I used to work early 2020, 21, where my interest on drones was much more. And the basic problem statement came from a fellow IISc working in a bank. Can you imagine? After finishing 4 years of BS, he does a master's from IIM Calcutta, then goes into a bank, and then he comes up with the unique problem. Says, can you build a drone that I can operate from my branch itself, which goes around, does a survey of the nearby farms, and comes back and tells me, is something happening on the farm was taken up alone, or they have not done anything. Based on a survey number, you know how far it is, go test and come back. So with that, started that problem. Then later problem, we said, hey, harvesting problem is there. So what are things that are there in a granary? How do you avoid rotting of grains? Right? Temperature monitoring, moisture monitoring, keep it dry enough, don't have enough work. Or if rats or any rodents are eating, you will see new gases forming, detect those gases and tell. So these projects used to do a lot of hobby projects and then move. Okay, now look, I will only now ask you to focus on what are written in the yellow boxes in the semiconductor space, because everybody has spoken about it. We'll only look at takeaways. I'll be really quick here. So when we say semiconductors, there was a sudden surge in the interest in India, or what they claim. But frankly, the semiconductor journey of India started in the early 50s. Right? Companies like Bharat Electronics came up developing the first semiconductor equipment like transistors, transmitting tubes, microwave tubes, all of these came into the being. And they were, for almost 20-25 years, they were the main lead of semiconductors in India. Then many companies like Gatech came into the picture, right, where they were doing MEMS manufacturing. ITA came in for the telecom, right? You had a very good presence of semiconductor in India. We lost the game in the 80s and 90s because our focus went elsewhere. The move went from semiconductors to manufacturing. So all the talent moved from there and all the interest from semiconductors died away. And it is in the early 1950s and 60s that you see, I think, SCL also came up around that time period. SCL initially was there, a separate entity, then it took up by ISR, saying it has to be part of the space. Why? That is where I am trying to emphasize that semiconductors is literally the backbone of every technology today. I don't think that the technology exists except probably plumbing, carpentry, okay, electrical work where semiconductor is not present. Otherwise, every other gadget that we hold, touch, feel has some kind of a semiconductor chip in it. So EV is important, defense is important, telecom is important, networking is important. All of these are important. So India started saying, we now to do a very calculated bringing forward of this activity further. So that's why the last decade you would see enormous emphasis on bringing back the semiconductor boom in India. And if you see, COVID gave a great example that global supply chain in semiconductors is very critical. And this is where everybody found that you are heavily interdependent on everyone. You just cannot say, I will neglect a particular country and I will just do it everything on my own. It's not possible. Everything is dependent. And I say probably with some confidence that the only country which may not depend upon any other resource outside probably would be Samsung in South Korea. They mostly have everything else within their mainland area. All the others have a dependence on every other country. So I would say semiconductors are not just a job sector, they are a very strategic national capability. Okay? So on multiple strategic deployments, mostly the defense or space or surveillance, you still need a lot of semiconductors. And And India is at such a inflection point that whatever the talent you build today will define the future tomorrow. So when you need to have the right amount of talent ready beforehand, before the technology comes up. If you do it reactively, you will again lose the race. So I think this is one such initiative where you're trying to go a little forward. So I'll talk about a few things, mostly on the value chain that we are looking at and where students can target. So the value chain basically starts from materials. A lot of people in India are not paying attention to the materials that are going behind it. Leave apart the IITs and some of the tier 1 universities, everybody else does not understand how important materials is to semiconductors. The device physics, process fabrication, design and verification, package and testing, systems and application, everyone else is somehow understanding. India probably is a leader in the design and verification space, where it is providing enormous services to global companies. And we also have been great with system and application. But there are still many critical roles present which students can aspire for. So I think core competencies everybody would have, but I give a mathematical equation which says the competency is a combination or summation of knowledge, hands-on skills, and engineering mindset. India is now taking care of foundational knowledge, building all of them. Where are we lacking? We are lacking at getting these technical skills done. What are these technical skills? Clean room processes and safety. Now, with a raise of hands, how many students in the back know what a clean room means? What is a clean room? Okay, what does the name say? Clean room. So room has to be very clean. How do you define clean? There are different classes of clean. So we create class 10, class 100, and class 1000, and class 10,000. What does that mean? Professor Sadev, please correct me if I'm wrong. In 1 cubic meter, meaning 1 meter by 1 meter by 1 meter. Typically, just imagine I'm sitting a cube of 1 meter cube. You should only have 10 particles. That is called a class 10 clean room. You know how much dead skin our human body releases? Once you enter and come, one human being, if they enter and come back, a clean 10 room might be non-qualified. That is the amount of dust that you deposit or you carry every time with you. That is why there are air showers every time you want to go into these places. How many of you have seen air showers? Students. Okay, now I think that is one AR I will give to our team, saying introduce each one of the students to a clean room, otherwise you don't have a proper exposure to the students. Second, ensure what is a air shower or an air curtain. Okay, without air curtains, dust cannot be regulated, including to the principal seated. We will inform that if you are taking them to an IV, no, that is not IV where you generally go. Take them to a clean room where IVs are there, and Kerala does have many clean rooms. Okay, the easiest clean room I know, which is accessible to students, is at IISc Trivandrum. We can go. A lot of IISc, my fellow batchmates are there. My senior is there, so please go visit. Because unless you go inside a clean room, you will never know what a clean room is. Okay, and how to maintain a clean room process. So this is first one. Second skill set. What are the various characterization tools? This is almost impossible at this point of time because nobody can afford so many characterization tools in bulk. But you can at least take them to visit them. What is an SEM? Can somebody tell me what SEM means or stands for, or what's its abbreviation? Single Electron Microscope. Okay. What is it used to? It is used to know the features of a surface, of a semiconductor growth that you have or a layer that you see in good magnification. What is a good magnification? 75K times. How much is that? 75,000 times if you zoom in, you can see. Or you are now looking at 250K zoom in features. Now, to do 250K zoom in, how much optical zoom in do you need and how much will be post processing? A typical microscope will give you 1x, 10x, 25x, 50x. Next, AR again to the management of mix. Show them magnification, how it happens. Take them to the labs where this kind of magnification is shown. Faculty members who have not seen, please see. It is necessity now to understand. Otherwise, there's no point talking about semiconductors without knowing the scale at which semiconductors are working. Okay. Third one, CAD and EDA tools. This I think everybody has. So I'll skip that. Fourth one, data analytics and modeling. A lot of work is already being done on. But what is the mindset here? You're all on a student mindset. Industry wants a engineering mindset. What is the difference between the two? It is an optimization problem. Okay? What does academia optimize? OBE. Objective based learning systems is what they focus on. What engineering focus on? How to solve a problem. You are not taught in the academia how to solve a problem because you are only shown a small portion of the problem. 3 questions Madam asked before. I hope she's there in the room. I'm not able to locate her. She asked, what are the various problems you asked? What are the challenges that you faced? You will never see those challenges spoken about in the academia. I think Rajesh and JJ will agree to me. What will they speak about? They say, okay, PVT, robust circuit design. People are struggling with analog circuit design. Robust circuit design is way ahead. Across all PVTs, same performance. You know what's the best way to explain this one? Comes from my experience when I working in Bharat Electronics, where I was asked to go to field to test one particular equipment sitting inside a tank. Okay? There's a tank. There's a tank gunner who is sitting in front. Next to him is the electronics that was working. This electronics box has to work. The outside temperature is 52 degrees. Tank is made up of good amount of steam. You sit inside, it is 62, 63 degrees. So in 63 degrees, with all the difficulty, the tank operator and the gunner have to look at the electronics for locking. The circuits inside work at much higher temperature. Now the same electronics box, without any other conditioning or changing, will be taken to Siachen or Kargil or Jammu and Kashmir, and it is made to work at sub-zero temperatures of -10. Reliably, consistently, and in that extreme cold and shivering, the gunner or soldier has to lock the target. The electronics is the same. You have to basically lock the target. But the conditions in which they are operating is different. Somebody asked PVT, right? This is true PVT. I'll give you one more PVT which space works on. When the rocket is getting launched, heavy vibration happens. So electronics have to sustain that vibration. And when an equipment goes to space, what's the temperature in space? What's the temperature in space? What's the pressure in space? Look at the designs that ISRO and its all teams are doing, ensuring that they are working in space. Years together. So what we do in the consumer design is a very small range of that entire big space. The consumer electronics or automotive electronics is a very small space. You have to work in a very large space of design. So understand that circuit design has got a lot of things, and all of these happens with all these 3 terms very clearly. You should have a process discipline, documentation discipline, reproducibility discipline, and failure analysis. in circuit design, I think Rajesh will probably use your example that we don't learn a lot when things work. Because we follow all the checklists, we know they just work. But if it doesn't work, she spoke about pressure, right? Pressure is not when it works or when it fades out. Look at the pressure when $25-30 million IC doesn't work according to spec. That is pressure. And that is only felt by the first point of contact, not your junior engineers. They will bear minor profit. The responsibility pressure, the accountability pressure. That is a different kind of pressure. You will see a lot of semiconductor engineers aging faster during that pressure, not during its actual operation time. So the reason I use the word aging is also very important reliability parameter in semiconductors. Right? When you want to test the operations of a particular work, you have to test it for a 5-year period or a 10-year period. But how do? You do something called accelerated aging tests. Right? So after a very long time, I won a best paper award last year in ITC. We showed that accelerated aging is so essential. Many companies are not talking about it publicly. They do it internally, but they don't release data publicly. So from Intel, when we started releasing, they acknowledged that. Okay. Now I'll tell you, a lot of people are doing many things, but I'll show you real examples of what is happening in nanotechnology space or semiconductor space in India, and we will mostly of academic institutes, so that you can see why you can draw a parallel. The first one, my alma mater, the Indian Institute of Science. And I'll be a little biased to it because I have literally got it worked in those labs and exposure. So I'll probably speak about them a little more detail. So this is the main building of Sense, and these are the various facilities that they're using. And this second picture is called the gowning area, the footwear and the gowning area where you go and dress up in a particular attire such that you don't impact, introduce any dust or disturb the ecosystem. And this is the clean room which needs all of this effect. So people in the front row who have spoken in the panel who are very big experts in this area who have a very strong understanding of how it works. And it might feel silly that I'm speaking in front of them talking about these. This particular photo, though it has not come out properly, is actually a window. You're taking a photograph through a window of an equipment which is called your characterization equipment. This is the MNCF, the characterization facility, where you have many important characterization equipments. Now, what are these? Many more. So, you need to have this kind of an exposure to work in the fabs or to understand what fabs need. Second, the IIT Bombay's nanofabrication facility. This building, right, is generally the poster picture of the facility. But once you go inside that building, Javed, so if you go inside this building, you have all of these microfabrication works, and this center is famous for its MEMS works and a lot of layer work that they do in the microfabrication, and they have a lot of emphasis on measurement-driven engineering, from device physics to fabrication linkage. So this place looks at very, very strong fundamentals and disciplined experimentation. Next, we have the Center for NEMS and Nanophotonics at IIT Madras. So NEMS is, we have all heard of MEMS, electrical mechanical systems. From micro, this is got to nano, really small, same form factor. What do? This place, along with NEMS and Nanophotonics, corely they work on semiconductor research, but very interestingly, they have a nice understanding of the technology translation. They work well on translational research, meaning to take an activity, translate it into a market and product, and ensure it goes. So they say the way they speak is semiconductor competency must translate to products and manufacturing. Right? Learning has to have a known outcome. So in this particular place, they have a home to a lot of research to startup pathways. If you go to the IIT Madras Research Park, they have built a template like how IISc has FSID, Society for Innovation and Development, where they have clear paths to start up. You come up with a POC, TRL level 3, 4, 5, and then they translate it to a product fit enough to go into the market, and they guide you and mentor you. I don't know how many people know of this center. It's called Institute of Nanoscience and Technology. It's in Mohali. Mohali is home to a lot of things semiconductors. Just that people don't. There's an IISc in Mohali, SCL is in Mohali, this institute is in Mohali. Many things are there in Mohali, and Mohali is a place close to Chandigarh. So everybody calls it SCL Chandigarh, but it's actually SCL in Mohali close to Chandigarh. So this is a big place, a lot of activity happens. But many people in the northern India still are devoid of information that they are not aware. Let's come to some of the colleges which are run by private organizations. Okay, not by the government organizations like the previous ones. So this is by Vellore. So Vellore has got something called a VIT Vellore campus has Center for Nanotechnology Research, where they have a lot of equipments available, where they are using that to ask other colleges that come and use that center. What are they good at? They are good at carbon nanotube based sensors. There's 1 or 2 faculty who have driven a lot of that work, and they're doing some amount of semiconductor materials work that is happening. So if you really want to visit, which is easier, closer, this is another place we can easily visit in an academic setup to go visit. Lastly, I will talk about the NRC Center, which is called the Nanotechnology Research Center at SRM. This is one of the oldest privately run nanotechnology centers. In 2006 it was started. And they have a lot of research areas which till I was researching for this topic did not know myself. At least one half of this I was not familiar that they were capable of doing it. So please look at these topics, and these are great topics to look at. So now what is the mismatch that the industry and the academia looks like? So I say, when you graduate, you're still probably here. There's a lot of journey to solve before you are even industry ready in this space. So what are they? Internships, lab exposure, project ownership, failure stories. Academia is just entering the first point now. They have just started pushing for internships. 3 more steps to go. How you do it, I don't know. But it's probably an open ecosystem that you can look for, where you have to look for lab exposure. It's a great business opportunity. Just create a class 100 clean room. Use it as a facility just to showcase. Treat it like a museum. Let people come and see how does it look like. You'll probably get return of your revenue probably a couple of years.
In fact, there is a class 100 clean room here. You'll see like finishing 2 months.
Here?
Yeah.
Huh?
Well, it's an academic institution or it's in our
So you have a very nice resource here. So you know whom to reach out to next when you can, right? Next is project ownership. You have to take up projects and own them. And you know what is important? If you fail in them, talk about the failures. Failure stories are more interesting because it gives you a chance to learn, relearn a lot of things, and probably unlearn and relearn a few things. Okay, then you have to understand the difference between a research problem, a product problem, and a manufacturing problem. These problems are typically able to categorize in your TRL levels. TRL 1 to 3 is your research problem. TRL 3 to 5 to 6 would be your manufacturing problem or your product problem, or vice versa. And 7, 8, 9 is your, I typically call 7, 8, 9 as a sales problem, because you need to sell for the product to work. So working on this is important. So if you are a topper and you don't get a job, don't worry. But are you a problem solver? And if you don't get a job, definitely the institute has to worry. Because problem solvers are what the industry